Hi, welcome to part 7 of the video series about the vertical projectile motion. In the previous videos, we solved some examples to understand how to use equations in this topic. In this video, we are going to solve another couple of examples. An object is thrown upwards from a height of 20 meters with an initial velocity of 25 meters per second. How long will it take to reach a height of 50 meters above the ground? Assume no air resistance and g is equal to 9.8 meters per second square. As we've seen in the previous questions, first we choose direction of initial velocity as the positive direction. The magnitude of the initial velocity is 20 meters per second. Acceleration is negative 9.8 meters per second square as it is downwards. Initially, the object is 20 meters above the ground level. We are asked to calculate how long will it take the ball to reach the height of 50 meters from the ground level. Let's display all this information on a diagram. Initial height of the ball is 20 meters. It moves up to reach the maximum height. Afterwards, it falls down until its height becomes 50 meters. As you know, displacement is the change in the position of an object. In other words, it is final position minus initial position of the object. 50 minus 20 is equal to minus 5 meters. The value is negative, therefore we can understand that the object displays downwards, as we have chosen upwards as the positive direction. It can also be clearly seen on the diagram. We know from the previous video, if displacement and initial velocity are given, and we have to calculate the time, it's better to solve this question in two steps. First, we calculate the final velocity by using the formula v final squared is equal to v initial squared plus 2 times a times displacement. We can substitute initial velocity as 20 meters per second, acceleration is negative 9.8 meters per second square, and the displacement is minus 5 meters. Final velocity is negative 22,32 meters per second. While calculating the final velocity, we can note that it can get both positive and negative values. The reason we choose the negative one is the direction of the object at the height of 50 meters. As it can be seen on the diagram, it's moving downwards, which is considered as the negative direction. Once the final velocity is known, we can use the formula v final is equal to v initial plus a times delta t to calculate the time. We have just calculated the final velocity. Initial velocity is 20 and acceleration is negative 9.8. The time it takes the object to reach the height of 50 meters is 4,32 seconds. Unlike the previous examples, in example 8, an object is thrown downwards from a height of 20 meters with an initial velocity of 10 meters per second. What is its maximum velocity before it hits the ground? Assume no air resistance and g is equal to 9.8 meters per second square. We have mentioned in the video about the notes to keep in mind that in the topic of projectile motion, it is suggested to choose the direction of the initial velocity as the positive direction. In this question, the object was thrown downwards, which will be considered as the positive one throughout this question. Initial velocity is 10 meters per second, acceleration is 9.8, and the displacement is 20 meters. We are asked to calculate the final velocity. To solve the question, we can use the formula v final squared is equal to v initial squared plus 2 times a times displacement. Initial velocity is 10, acceleration is 9.8, and the displacement is 20. All these values are positive as all of them are downwards. Square of 10 is equal to 100. 2 times 9.8 times 20 is 392. Square of final velocity is equal to 492. To calculate the final velocity, we take the square root of this value. The final velocity of the object is equal to 22.18 meters per second. In the next video, we are going to solve last two examples regarding the equations. Thanks for watching. Don't forget to subscribe and turn on notifications in order to be updated about the new videos.